talk through the normal distribution packet problems on the MyAP website. So I'm just going to take the answers that I had up there already and talk through them, because sometimes on a piece of paper it's not super easy to follow what I'm doing. Okay, so this is kind of just definitions you should know. If they're talking about population data, which is the big picture, that's like everyone, those are called parameters. The mean is represented with this mu, and the standard deviation is the sigma. If it's from a sample, so you're just taking like a little piece of the puzzle, those are called statistics. The mean is called x bar, the standard deviation is this little s. And so as the year goes, you'll be responsible for knowing, if you see this, okay, that's a sample mean. If you see this, that's a population standard deviation, and these symbols matter. So for here, because they said parameters, when I was reading through this, I was like, I'm not really sure if this is supposed to represent all of the ATMs, or if it's a sample or what, but then it said parameters. That means population, so there's your mean standard deviation. Second one, so these are pretty typical. You'll see a few of these on here, but they give you a mean, standard deviation, and then an x bar, like your little sample data. You find the z-score, and then you look up this z-score in your chart. So just to walk through doing that, I probably won't do every one of these, but I'll show a couple. So negative 0.947 is your z-score. So I'm looking at this chart. I have no idea if this is even helpful on video, but we'll do our best. So negative 0.9 is here. And I'm basically looking for negative 0.95 because 947 isn't really on here, and I get this number here, this 0.0711, and I'm getting that by looking at the 0.05 and the negative 0.9. And then this number, the numbers in here, are percents below. So these are percents, and they're percents that are less than the z-score. Because that's what they're asking us for, we just read that number. If it said more than, then you would flip this around and you would make this 0.83. Number 3, so they're trying to get you to compare how a student did in Chem and Calc. So because the means are different, you can't just look at it and say, well, they got an 84 and they got an 81, so they did better. That's not necessarily true when you compare it to the average. So if we start comparing to the average, that would be, like, let's get a z-score, and we find out they're both 0.5, so they both did equally as well relative to the other students in the class. 4, the answers are on the next page. Let me show the work here. So a z-score of negative 1.2. So again, I'm starting with this formula. I know z, I know x bar. I'm looking for x bar. I know the mean, I know the standard deviation. I'm getting those from this table up here. And then I'm just solving that with algebra. Get down to 779.4. Number 5, don't do this. This is garbage. I started to do way more work than I needed. So they gave me the z-score. So, okay, first of all, 1.2 standard deviation is above the mean. A few people I talked to were thinking that meant the standard deviation was 1.2, but it's really standard deviation is above the mean. This is your definition of a z-score. So they're giving you the z-score, not the standard deviation. So that took the z-score, and I was like, oh, I know z-score, I know x bar, I know mu. I'm probably supposed to find the standard deviation, but they don't care about the standard deviation, so I was doing way too much work. They want to know the percent greater than 35. So you found the z-score of 1.2. You look up 1.2 in the z-table. So I'm not going to show the z-table this time because it's super tiny and hard to read, but you get 0.8849. And again, that represents this area to the left, but we want to know the area above. So we do 1 minus that, and we get what we're looking for, this 12%. Number 6, again, answer on the next page, but I'll show this. So we got a male and a female grizzly bear. And the first thing I do with these problems, like this is just a mess of words to me. And some of you are better at it than me. I'm looking through and kind of absorbing, but I wrote down this stuff first. Male, Z, and I just started writing down, like, what do I know? Okay. The male was 530 pounds. The mean was 500. The standard deviation was 50. That 0 was crossed off. And then z-score is 0.6. Okay, so for female, we want the same z-score. So 0.6 goes there. We're looking for their weight, their mean, standard deviation. Then we can do our algebra on this one. And gets the answer, so it's 324. Number 7. So a z-score tells you, so a z-score of 1.72 means relative to everything else, we're 1.2 standard deviations, 1.72 standard deviations away from the middle. Well, then they're going to convert them to minutes. So basically they're going to divide every single thing in there by 60. That means every score will be divided by 60, and it also means the standard deviation will be divided by 60. So relative to everything else, when you divide everything by 60, this is going to be like a much smaller, like condensed normal curve, but your z-score will not change. Relative to everything else, if you did one standard deviation better than everyone else in seconds, then you did one standard deviation better than everyone else in minutes. The z-score won't change. Same thing with number 8. So we multiply everything by 100. Z-scores won't change. So the data is treated all the same, which I don't know why you would ever treat some pieces of data differently than others. That wouldn't make sense. If the data is all treated the same, the z-scores do not change. Like I'm taller, I'm the same relative taller than you are. No matter if we measure in inches, feet, meters, it doesn't matter. I'm going to be kind of the same place on the right side of that curve, no matter how we measure it. Number 9. So z-score of the third quartile. So when I first saw this, the first time I saw this question, I was like, okay, 75%. So I'm going to find out where 75% is. But then when I read through it again, this not symmetric is a big deal. So you can only use this z-table if it's normal, because it's normal distribution probabilities, and this one tells us it's not. So we're kind of stuck. All right, number 10. There's a couple different ways to answer this, but for a true normal distribution, you want some scores to be 2 standard deviations away and 3 standard deviations away from the middle. Not very many, but you want something, and this is just not. So you get the lowest z-score is only negative 1.33, and usually you should have z-scores of negative 2, negative 3, and so there's a couple different ways to phrase that, but basically the min and the mean are not enough standard deviations away from each other. Part B here, so 370 minus 310 divided by standard deviation, 2.4 standard deviations above the mean. So that's the interpret. So make sure you say that part. And then for part C here, for player A, I found these 2 z-scores. And remember, this is running, so negative is actually better. So for running, player A is a full standard deviation better. And for weightlifting, they're barely worse. So they're much faster, only slightly less strong. And so based on just looking at those 2 things, I would take player A. Number 11. So we got an X bar, a mean, a standard deviation. We get a z-score. This says greater than 2. So we look up the z-score of 2 in the table. But that's going to tell us the percent below. So the z-score will always tell us this, and then we do 1 minus that. So in this case, your z-score is 0.9772. And again, that represents that side of it. So on this side, it's 1 minus that, and that's why I'm getting that 0.023. Number 12. So you just kind of drawing out what they tell you. And I did it on part A and then realized I was done because that was the answer. So mean of 80, standard deviation of 2.5. So then over here, we're subtracting 2 standard deviations. That makes it 75. Here, we're adding 1 standard deviation. That makes it 2.5. And then that was it. So that was what they're looking for. Part B, that's the definition of a z-score. How many standard deviations above the average are you? 14. 14 is a little bit goofy sometimes. So all they tell you is the mean is 720. The mean is 720. They don't give you a standard deviation. And then they say which of the intervals will contain the largest proportion. Well, if you start just looking at their numbers, they're all kind of 20 apart from each other. So if you wanted to, okay, 700, 720, 740, 760, go the other way. And if you just start kind of drawing in these things, 740 to 780, yeah, those are 40 apart from each other. But you're like way in this tail, so you're just not accumulating very much area over there. 700 to 740, bam, we're right in the middle. If I've drawn it right, you're getting the absolute peak in that situation. 680 to 720, again, you're not getting the middle. You're getting a decent amount, but you're not getting the absolute peak. And the same with these two. So you want to take the one that's centered, because most of the data is in the middle if it's drawn correctly. All right, number 15. Some of these, like, this is not that hard of a problem, but there's just so much. So you just start grinding through what you know. So I see small puzzle and large puzzle, small puzzle time, large puzzle time. So I right away went down here and went small, large, and just started, again, words just, I don't think this way. So some of you do, and that's great. But if you don't, my advice is just get it out of this wordy paragraph as soon as you can and put it into a format that is organized how you want it. So the z-score for small ends up being 1. Z-score for large ends up being -1. And we want times greater. So we're going to look up z of 1 in the chart, and this came out to 0.84. But that's less than. We want greater than. Look up -1 in the chart, and that's 0.16, but we want the other side. So that's at 0.84. 16. So calculate, interpret the standardized score. That's a z-score, so you're going to calculate it, and then you're going to say it's the number of standard deviations above the mean. What proportion had a finishing time less? So you're going to find her z-score, look at the chart. Chart tells you less, 0.66. Standard deviation greater for women. Well, standard deviation is the average distance from the mean. So you might have something like the men all kind of finished in this cluster, and the women were a little more. So that would be a bigger standard deviation. What that means is the women's finishing times were just more spread out. The men kind of finished all together, and the women were like someone came in and later. There was just more distance between their times. 17. This 17 is very tough. Do the best I can to explain it. So Duncan, 32 percentile. So there's two 32s. I'm kind of indicating which one I used where. 32nd percentile. So I looked up 0.32 in the table, and I got -0.47 for my z. And then I just wrote this here to remind myself. Okay, these numbers go together. Z equals -0.47. X bar is 32. I did it again for this 62nd percentile for Shane and got a z-score of 0.31 when X bar equals 34. And what they're saying is, where's the mean? And so I'm not even going to actually calculate. First of all, I know the mean has to be between 32 and 34. Because this z-score is negative, so it's to the left of the mean, and this z-score is positive, so it's to the right of the mean. So it's got to be between 32 and 34. So that one's out. Well, it's not 33 because it's not right in the middle of these two z-scores. If this were like z is -0.47 and z is 0.47, then you'd be like, symmetric on each side, and you could say, oh, they're perfectly symmetric. What's right between 32 and 34? 33, you'd be done. But that's not the case. And then you got to look at, so a clue here is there's two answers between 32 and 33. There's only one between 33 and 34, and this is actually the one you want. And I'm going to try to explain why. So, this distance here from the mean to that z-score is bigger than this distance here. So, if I were to try to center this, okay, I'm not trying to center it. I lost myself for a second there. If I want to put, so right here, z equals 0, right in the middle. So is z equals 0 closer to the 0.31 that's over here, or closer to the -0.47 that's over here? The answer is it's closer to the 0.31. So therefore, your mean has to be closer to the 34 than it is to the 32. So there's my number. I didn't find the exact number, but I was able to kind of process through. And that's tough. 18 is a fairly standard one. Plug in 800, the mean, standard deviation. You're going to get a percent, or you're going to get a z-score. Look it up in the table. At most 800. So that would be like, 800 and everything below it. And so you do want to look at the table and just look at that number. And you get 19. So what I did here, what percentile is the layest height? Okay, percentile is just percent below. So Aaliyah. 0.96, and then I looked at the table, got 83.15%. Jane was 93rd percent. I had to look in the table to get that Z-score. So I went 0.93. If you're going to go in the table, and you're doing it backwards, this is a little goofy, so I'm going to walk through it. You know the percent. Well, the numbers in here are the percents. So you're looking for 0.93, not along the outside, but in the middle. So I'm trying to find, like right there. 0.9306 is about as close as I'm going to get. And that gets me 1.48 is my Z-score. So I got 1.47 here. I must have just looked at the different number. And that's fine. It's not going to make that much of a difference. So what percentile is Aaliyah's height? I know that because I looked in the Z-table, and I also know that she is shorter than Jane because her Z-score is less than Jane's. So 83rd percentile, and she is shorter than, 83rd percentile, and she is shorter than Jane. I was all zoomed in for the table. Number 20. So it's kind of weird because they're not even asking me for an answer. They're kind of asking me for the formula to get to it. But the process is the same. So 75th percentile, look in the table, look in the part on the inside for 0.75, read it out to get your Z-score. Z-score is 0.67. Once I know that, I know Z is 0.67, I know the mean, I know the standard deviation, and you can't really solve it. But if I imagine like multiplying both sides by 4 and then adding 36 to both sides, this is what you'd end up with. And they're just putting it in that format for whatever reason. Instead of, getting the answer. 21, so we give me this fairly straightforward. We get 35 minutes I got because that's how long it is between 8:25 a.m. and 9 a.m. Normally it takes them 30. So 35 minus 30 divided by 5 is the Z-score of 1. Look that up in the table. That's going to be 0.84, but then it's later than. So if it's earlier than 9 a.m., it would be 0.84. If it's later than, we're going to flip that and make it 0.16. 22. So again, I just started drawing this one out on the first page, and A was the answer, so I was done. It just matched. So the mean is 0.8, standard deviation is 0.25. So to get to 0.55, I got to go 1 standard deviation this way. To get to 1.3, I got to go 2 standard deviations this way. And they're just representing that in a different form here with that little notation. 23. So we got 1400, mean, standard deviation, Z equals 1. Look up the table, you get 0.84, but because they said exceed, you take the other side of that, or your 0.16. 24. This seems to trip people up a lot. You can compare these however you want. You can get them all into percentiles. You can get them all into Z-scores. It's kind of your only two. I chose to get them all into Z-scores. So R, they told me the Z-score. I didn't have to do anything. S is the value of the first quartile. So I looked up 25% in my Z-table, found negative 0.67 was my Z-score. 20th percentile, I looked up 20% in my Z-table, found my Z-score, and then I'm just putting them in order from lowest to highest. Remember, negative 1 is your lowest here, and then negative 0.84, and then negative 0.67. So this would be RTS. RTS. 25. I was surprised this is on the AP test because it's just a little twist at the end that had never seen in any other question. And yes, you technically have seen it before, and you technically should know it, but I don't know how many of you would have thought to get this far. So I looked up 10%, got the Z-score, looked up 20%, got the Z-score, and then I set up these two equations, and you'd have to use systems from there. So you could do elimination, you could do substitution, you can kind of do whatever you want. I'm not going to go through that part. It's not like the main focus of this chapter for me. If this were on the test, I would make it an extra credit 26, look up 99% in the table, get your z-score, and you got this formula. Multiply by 2, add 65, and you should be there. That gets us to 70. 27, kind of working backwards a little bit. So again, they give us the percent, not 10% longer. So if there's 10% above, we're looking for 90% in the table, because the table doesn't talk to us about above, it only talks to us about below. And this z-score does both jobs, if it's 10% above and 90% below. So we get a z-score, we know 30, we're looking for the mean, and the standard deviation is 3.5. I don't know why I have a signal there. So I multiply both sides by 1.28, do some algebra, that'll get you hopefully to 26. 28, so you got these two groups. You got a group like the kind of the lighter weighted football players, 200, and then they might go from 150 to 250, and then you've also got another group, a 300, and you get these two kind of mounds. That's a bimodal distribution. You got like two centers, two pieces, two normal curves kind of together. 29. So 29 and 30 are similar. So they give you a curve and they tell you which of these is the best for the standard deviation. So your options are on the next page. So it's like 5, 10, 30, 50, 60. So if I just start thinking through, like, okay, what if the standard deviation was 5? The middle is 55. That would mean if I go one standard deviation each way, I'm supposed to have 68% of the data. And it looks a little light, but I'm not quite convinced yet. If I go 2 standard deviations each way, now I'm supposed to have 99% of the data. And I just don't, that's still a little light. If I go 3 standard deviations each way, I'm supposed to have 99.7% of the data. And again, it's just not quite fitting my eye and the percents the way I want to. But if I make the standard deviation 10, 68% of the data between there and there, 95% between there and there, 99.7 between there, and it just fits. If you made it 30, well, now you go over to 80 and 20 and say, okay, 68% of the data is supposed to be in between there, but it's basically 100, 99 point something. So these are all way too big. So you're just kind of trying to fit it in there the best you can. At 30, same type of thing. I think they give you the same options. It's almost the same questions. 2.5, 10, 20, 50, 90. Well, if I go 10 each way, 68% of the data should be between there. That seems reasonable to me. If I go 20 each way, 95%. If I go 30 each way, I should have basically all of it. And that fits really well, and the other numbers just don't. So your best guess, your best choice is 10. 31. So find the score x above which. So 33% above means we look up 67% in the table. We get a z-score. And then you don't even have to solve the formula. They're just saying set it up. Yeah, so hopefully that helps. Let me know if I can help more. We'll do a little bit more review on Monday, Tuesday, and your quiz is Wednesday, Thursday.